Math 3, Unit 8B. Today we're going to talk about other types of regression. And so basically what it's saying is that we've talked about lines of best fit. So they're not the exact line, but a line that makes sense for the data that is given. Yesterday we mainly talked about linear models, and sometimes linear or lines aren't the best choice. And so we can fit data with all sorts of curves. The most common are linear, exponential, and quadratic, but there are many other types. So before we look at exponential and quadratic regressions, and that's typing the information into our phones through Desmos or on the computer, recall the general shapes of these two types of functions. So remember with exponential graphs, for instance on this graph right here, all of the data is increasing. So I'm just going to put here, all data is increasing, which means on this one, all the data is what? Good. All data is decreasing. And then it's usually at a very high rate, okay? Quadratic graphs, if you notice, this one is going from decreasing and then it changes to increasing. Or on this one, it's starting and it's increasing and then it changes to decreasing. So quadratic graphs always increase and decrease. Okay. Any questions so far? So for this first exercise, it says for each scatter plot shown below, determine if it's best fit with a linear, exponential, or quadratic function, and draw a curve of best fit depending on your choice. And I also want us to say whether it's like a positive or negative additionally. Okay, so on A, do we think that would be best served as linear, quadratic, or exponential? Good. And so you can see here how it's all kind of going up. And so we're going to make a curve kind of best fit. I wouldn't say that I just drew that great. Remember how when you're doing your curve of best fit, you want some above, some below. Okay? And so we would call this exponential. And would this be increasing or decreasing? Increasing. So I'm just going to put increasing below. Or if you put positive, that also works. Okay, B. What type of best fit would this be? Quadratic. Very good, quadratic. And so we draw our line of best fit. This is quadratic. And specifically, this would be, well, it's always increasing and decreasing. Good. But in terms of quadratic functions, the a value or whatever, we would label this as a negative. So I'm just going to put negative underneath. And I like that you noticed that it was positive and negative, or both increasing and decreasing. Good. Okay, C. Exponential. Good, exponential. Okay, and this one would be what type of exponential? Decreasing, good. Okay, what about D? Very good, linear. And if on this linear, is that a positive or a negative? Very good. And so remember that we read lines and graphs going left to right. And so we can see that starting left, this one's going down, which makes it negative. Okay, and then E would be what? Linear, but this one is positive. Okay, and the last one, F, is quadratic. And this one we would call it a positive quadratic function. Good. Okay. So far, so good? All right. Okay, our calculators can produce equations for exponentials of best fit and quadratics of best fit, along with a lot of other types of curves. So if you think about what we did yesterday, when you're typing, you know how we typed in our equation like y1 is approximately equal to mx plus b, all you're going to be doing is in these programs, you're going to be typing in a different type of equation that you're looking for. Does that make sense? And so we can go through all that. All right, so exercise 2, biologists are modeling the number of flu cases as spread around a particular city. The total number of cases, y, was recorded each day, x, after the total first reached 16. So on day 0, they basically say day 0 is when it first outbreaks and there were 16 cases. So they're basically saying before that it wasn't a problem. The data for the first week is shown in the table below. So using our calculator or our phones under Desmos to find the exponential regression equation for this data set in the form of y equals, and it has ab to the x power. Because remember, exponential functions have x in the exponent, okay? And then it says round all parameters to the nearest hundredth. And so make sure that you are always looking for that. Okay, so we're gonna go ahead and use our calculator or our Desmos graph. Let's see here if I can make this so it looks okay. Just kidding, that did not help. Oh, that's because my computer turned off. There's my children, just in case you guys want to see them today. Oh my goodness. Okay, here we go. So you can be using the computers again or your phone. So we're going to start by inputting a table. And so I'm going to start with all my x values going down. So we have 0, 1, 3, 4, 6, and 7. And then we're going to put in all of our y data. And that is 16, 18, 22. I don't have the right data, do I? I'm on the wrong page. I do? Yeah. Okay, good. Okay, and 25, 33, and then 35. Okay, everybody, so far so good? Now, the equations, did you guys remember how to put them into the second spot? Good, so we're gonna use, and you guys can't see what I have up here very well right now, sorry. Okay, so since this says y1 up here, we need to make sure we write y1 for our equation. If we just write y, it won't work correctly. And then to get our approximately equal sign, we have to press the ABC button because it's going to take us to the next set of symbols and letters. And we do our approximately equal button, which is down here at the bottom right. Okay, now on this one, what type of equation do they tell us to do? Exponential. So we're going to write it exactly as they have here, and let's see what happens. So we are going to go A, and then parenthesis, B, and then we need to get to the x power. Do you guys know what we're going to do for that? Very good. Other page. And do you see how there's an A squared button and then an AB button? Well, since I'm wanting a letter in my exponent, I'm going to press the A to the B button, and then now I can put an X there. Say that again. And what did I do wrong? Very good. So I need to make sure that I put a 1 with the X so that it works correctly. And so anytime it's not working right, you just need to look. Did I forget the 1, or is it a 2 instead of a 1 for this graph or whatever it is? Okay, so now we have our equation. And so let's go ahead and write our equation down. Okay, so I'm going to take this away. Why? And one more thing. Why can't I see the graph right now?
Because it's not in the range.
Yeah, it's not in the range. And so if I just want to zoom a little bit here out, we can end up seeing it. And we can see there now that it is a exponential function. So it's a little bit easier to see. Okay, so I'm going to take this away here for a minute. And so what am I going to write my equation as? And again, we're rounding to the nearest hundredth. So it's going to be y equals, what was the a value that they set on there? 15.91. And then parentheses, what was the b value? Good, 1.12 to the x power. Now what you have to be careful about is when you're taking like the SBAC test or whatever, if you need an exponential equation, you need to make sure that you write it as an exponential equation, not a linear equation. Because if you typed in for a linear equation, it would be something completely different, okay? And in fact, if you remember from the practice SBAC, there'll be a calculator on there that will actually do the same kind of stuff for you, okay? All right, so then it says, based on the regression equation, how many total cases of flu will there be after 2 weeks? The first thing you have to decide is 2 weeks, what number am I going to end up plugging in? In days, good. So if x equals 2 weeks, we would end up converting that because everything in my data table is in days. So that would be 14 days. And so now we're going to go y equals 15.91 times 1.12 to the 14th power. Now, I would suggest putting all of the data in your calculator at once. Oh, and you know what? I should probably use the calculator you guys use. It gives you kind of more accurate data. You don't have to, but what I mean by this is if I go, if you can see there, 15.92, and then I can do a parenthesis, and I'm going to do 1.12, close my parenthesis, and then I raise that to the 14th power.
This is also,
It's 15.91.
yeah, 15.91.
Just kidding. Hold on, I can't see when it's up there. Okay. So see how we can plug everything into the calculator at one time, and then we press enter, and I get 77.754. But it's, when you're talking about cases, what would you round this to?
78.
78. And basically, when you're talking about people, oftentimes you might always kind of round up. But so we're going to call this 78 cases. Okay. Questions so far? All right. The next one says, according to your model, by what % are the flu cases increasing on a daily basis? We haven't really gotten into this before. Does anybody have any idea? Based on what you've learned maybe in your science classes? You're close. It has to do with your B value. Okay, so my B value is 1.12. This is my multiplier. And what I mean by that is that we're always raising it. We're taking 1.12 and we're multiplying it to whatever power. And so what is happening is that this really is 1 plus 0.12. And so 1 is where you're starting with, basically. And so this right here, that is how much it's increasing each day. So 0.12 would be what percent? 12%. Good. So it's 12% per day. So if this number had been something like 2.112, then it would have been what per day? 112%. Does that make sense? Okay.
So you always just take the first number off.
Or you take 1 off, basically.
Oh.
Okay. All right. Hospital officials will declare an emergency when the total number of cases exceeds 200. On what day will they need to declare this emergency? Okay, so we need the answer to be at least 200. Does that make sense? So it's like we're going backwards, okay? So if we're looking at our equation, we would write 200 in the y spot because we're wanting to know when will it equal 200. Equals, and then we have our 15.91 times 1.12 to some power, okay? Because this is where my days are, right? X equals the days. And so we're trying to figure this out. Well, how could we figure this out?
You could divide. Or we'll multiply it out.
Well, okay, and what you're thinking about is the way I thought about it originally too, just so you know. I thought, okay, I can divide by 15.91, and then you could figure out 1.12 to what power is going to give you 200. And the only way to do that would be like guess and check, right? So we know that after 7 days it's 35, so we know we have to go obviously bigger than 7 for my X value. You can actually even do it within your computer programs. If you wanted to like look at your graph, let's go here for a second. And maybe it won't be able to see very good. So we want it around 200. So we're kind of guessing like where is the X value going to end up being kind of around 200. So if you're looking at this graph on your computers, do you guys have an idea of what the X value might be when it hits 200? And you can't see the lines as well right now, but this line right here, like going straight up, it's 25. And so it looks like 200 is around 25, but not quite 225. Okay? And so what I think we should do is maybe just make a T-chart, and we're going to kind of guess and check where I'm going to plug in. Let's start with, I don't know, should we start with like 22?
Yeah.
Okay, so we're going to start with 22 and plug 22 in here. So we're just going to use our calculators. Is that good? Okay. And in fact, well, I'm just going to rewrite it. Okay. Try to make it so you can see. Okay, so we have 15.92 parenthesis 1 point. Did I do the same thing again? It's because on my notes I had it's 15.91, right? Times 1.12, and then we are going to raise that to the 22nd. And when we do that, we get 192.5. And it needs to be greater than 200, right? And so we would call that 193. Are we all good with that? So we're just going to round it because we're talking about cases of people. And so I'm pretty sure 23 is going to give us our answer, but we'll go ahead and plug in the information just to be sure. And so again, I will type in 15.91 parenthesis 1.12. Oh my goodness. Thank you. All right, and then we're raising this now to the 23rd power. And I'll put it back up here in just 1 minute. Okay, so again, I put in my equation into the calculator. I'm going to press enter, and we get 215.6, which is 216. And so that means that they will declare an emergency when?
After 23 days.
Very good. So 23 days. All right. Any questions?
So the number can be above what you're trying to get at?
Yes. And in fact, I was going to actually go back to that. Thank you for saying that. Really, because they're going to declare it when it exceeds 200.
Oh.
And so we really would want to make this where 200 is greater than the equation. Okay, other questions? Okay. So it says, so really regression, as mysterious as it may be, is all about finding the best version of what curve we think would fit your data set. Okay? Exercise 3 now. The cost per widget produced by a factory generally drops as more are produced, but then starts to rise again due to overtime costs and wear on the equipment. Quality control engineers record data on the cost per widget compared to the number of widgets produced. Their data is shown below. Okay, so what do we do, what type of graph do we normally use when you have increasing and decreasing within the same data set? Quadratic, very good. And within quadratics, we know that there's always a minimum or maximum. And we talked a lot about that last unit, didn't we? And so always wanting to find what is that point where you're going to get your maximum or minimum return depending on what you're wanting. And so on A it says, why should a quadratic model be considered for this data set as opposed to linear exponential? And we just talked about that. So what would be my answer? So why are we using a quadratic? Because
It has increasing and decreasing.
very good. So we use quadratic because the data outputs are increasing and decreasing, or something to that effect, as long as it makes sense to you. Okay, and then B on this one is just asking us to use your calculator to create a scatter plot of this data to verify the quadratic nature. So we're just going to go back to our graphing system and plug it in to make sure, because looking at this, it doesn't necessarily look quadratic to me. Does it look quadratic to you? Or maybe it does. Like when you look here at the x values, the x is always increasing, right? It doesn't always have to, but in this case it is. But when the x is increasing, see here it's at 9, and then it's going down to 2, down to 1, still at 1, but then do you see now here it's going back up and up. And so that kind of gives us the idea that the data is changing, okay, and going from increasing to decreasing. So we're going to plug these values into our graphing Desmos. And again, you can do whatever you want to in terms of using your phone or a computer. So I'm going to get a new table. And this one, my x values are 35, 88, 110, 135, 154, and 190. And then my y values, 9.32, 2.63, 1.42, 2.12, and 5.50. Okay. So when you're looking at this right now, do you see, does that look quadratic to you? No, and so we're going to want to change our window, okay? And so talking about maximum and minimum values, if you're looking at your x's, okay, what's the minimum and maximum value on the x's? 35 and 190. So normally you want to do like your x, let's do our minimum for x is going to be 30, and our maximum for x, I'm going to do 200. And so I think I showed this to you yesterday, but if I didn't, we're going to talk about it here right now. So right here, this tool, we can change our window, and I can do specifically. So on my x-axis, I want my smallest value to be 30, we decided, and my largest value to be 200. Okay, now looking at the y's, which values? So my largest value is what? 9.32, right? So we're going to call our largest value is going to be 10, and then my smallest value will say what? 1 or even 0. Okay, so however you want to do that. So my smallest value I'm going to put as 0, and my largest value I'm going to put as 10. Okay. And then I'm going to go out. And as you can see here, here is my quadratic function. So it looks a lot more like a parabola now that I've changed my windows. Yes? And we could end up going over here and having the equation written for us if we wanted to. But they didn't ask us to on this one, so we won't really worry about it. And so based on what you have here, we verified it, that it is a quadratic function. And then let's just go ahead and just draw like a little graph here for ourselves. And so our graph just kind of looked, you know, like that once we changed our window. And again, I'm going to put on here that we changed our x min to 30, our x max to 200, and our y min, I changed that to 0, and my y max, I changed that to 10. And so oftentimes when you're dealing with this, you're going to want to change your windows to actually see what the graph looks like. But it's pretty easy to look at your data, right, and decide what is your biggest and smallest values and go somewhere around there. Okay, any questions?